What is refraction? Refraction is actually change in the path of the light ray when it travels from one transparent medium to other transparent medium. Suppose this is air and this is glass, and light travel from air to glass. Light travel from air to glass. Air is comparatively rarer medium and glass is denser medium. Why air is rarer in comparison to glass? Because light travels faster in air than in glass. So when the light travels from air to glass, it deviates from its path, and this phenomenon is known as refraction of light. So when the light ray is traveling from one medium to another medium, why the light ray refract? That we have to understand. The cause of refraction is the change in the speed of light. While traveling from one transparent medium to other transparent medium, if the speed of light decreases, then it bends towards the normal. For example, light traveling from air to glass, it bends towards the normal. So you can see here angle of refraction is less than angle of incidence. But when the light ray travels from glass to air, glass is denser medium and air is rarer medium. In such case, the angle of refraction is greater than angle of incidence. So we can say that change or deviation in the path of the light ray when it travels from one transparent medium to other transparent medium, that is called refraction of light. And when the light ray travels from rarer medium, this medium is rarer medium and this medium is denser medium. So when the light ray travels from rarer to denser medium, it bends towards the normal, and when the light ray move from denser to rarer medium, like this medium is glass, suppose this is denser medium and this medium is air, that is the rarer medium. So rarer medium and denser medium, how we differentiate? Out of these two mediums, where light travels faster, that is rarer medium, and where light travels slow, that is called denser medium. Suppose this is a glass slab. If the light ray is incident on the glass slab normally, then it will be going straight without any deviation. So if the incident ray fall normally on the surface, refracting surface, then the light ray deviate normally. So what is the cause of refraction? You can say cause of refraction is change in the speed of light. Change in the speed of light. Okay, in this case you can see speed of light in air is 3 into 10 to the power 8 meter per second. But the speed of light in glass is less than that. That's why the light ray is bending towards the normal. Here the speed of light in glass is less than 3 into 10 to the power 8 meter per second. So it is bending away from the normal. So whether it will bend towards normal or away from normal, on which factor it depends? It depends on the factor that whether the speed of the light during refraction increasing or it is decreasing. Now let us discuss the laws of refraction. The first law is the incident ray, refracted ray and normal at the point of incidence lies on the same plane. Means this is incident ray, this is normal, this is refracted ray. all these three lies on the same plane. So this is angle of incidence I, this is angle of incidence R, and all these lies on the same plane. This is the first law of refraction. And second law of refraction is the value of sin I by sin R remain constant, and that is known as refractive index of second medium with respect to first medium. For different values of I, if you see different values of R, then sin I by sin R, this ratio for a pair of medium always remain constant, and this constant is known as refractive index of second medium with respect to first. What is first medium? First medium is the medium where incident light ray fall, and second medium is the medium where refracted light ray fall. So refractive index of second medium with respect to first medium is sin I by sin R. For various angle of incidence I, if you measure the different values of angle of refraction R, then we find that the ratio of sin I by sin R always remain constant, which is known as refractive index of second medium with respect to first medium. Now this mu we can represent in terms of speed of light. We can represent it in terms of the speed of light. What is refractive index of second medium with respect to first medium? That is equal to C1 by C2. What is C1 and C2? They are speed of light in medium 1, and medium 2. Now let us take an example to understand this equation. Refractive index of glass with respect to air is 1.5. What is its meaning? Its meaning is speed of light in air by speed of light in glass is equal to 1.5. From this equation, you can also calculate the speed of light in glass. How can you calculate? Ca is 3 into 10 to the power 8 meter per second. All of you know speed of light in air is 3 into 10 to the power 8 meter per second by speed of light in glass equal to 1.5. So what is speed of light in glass? It will come 2 into 10 to the power 8 meter per second. So this is the second law of refraction, and this is how the refractive index is related to the speed of light. Now let us see the effect of speed v, wavelength lambda, and frequency f. When the light ray is refracted from rarer to denser medium, the speed of light decreases. As I told you that light ray was coming from glass to air, so its speed was increasing, air to glass, its speed is decreasing. Similarly, the term frequency, F is frequency. Frequency of light depends on the source, and during the refraction of light, the speed and wavelength changes. V is the speed and lambda is the wavelength of light. Lambda is the wavelength of light. So during refraction, the speed and wavelength of light changes, but the frequency of light do not change, because frequency depends on the source. Frequency depends on the source of light. And how they are related? They are related according to the mathematical relation V equal to F lambda. F is the frequency and lambda is the wavelength. Now speed of light is in different media, and the relation between refractive index and the speed of light in different medium already we have derived.